All right, so we're going to talk about the power property next. And again, this is, like I've said in every one of these videos, understanding the power property depends on understanding the properties of exponents. In particular, here it's the power of a power property for exponents, right? The power of a uh, power of a power property for exponents. All right, so you know that the power of a power property says that when you're raising a power to another power, we multiply the exponents. Now just remember that the log is the exponent. So here, the we've got a power, or we got a, if we think of m as being a power of b, which you can always write any number as a power of b, then essentially we've got a power raised to a power, right? So, and the log is the exponent. That's always the important thing. The log is the exponent. Now, this is a very important property because it allows us to bring the exponent out front. So you may have learned it as, you can bring the exponent out front if you have a log, if you're taking the log of something with an exponent in it. And this is another important property that allows us to solve exponential equations. So again, I have a little more formal proof here. You can read through it and see how it works. But let's dive in and start using it. All right, so in the first is example 5. Well, this example is asking us to solve for x in terms of the log of 2 and the log of 3. Okay, so we want to write our answer in the terms of the log of 2 and log of 3. All right, so we want to solve for x. So, all right, the power property allows us to rewrite this logarithm as x log of 2 is equal to 3. Okay, that's just directly applying the power property. And so if I want to solve for x, I just divide both sides by the log of 2. So I get 3 over the log of 2. Now the log of 2 is just a number. It's just, you'd have to put it in your calculator to find it. So if they're asking for the exact answer, this would be the exact answer for a problem like this. We just leave it in terms of the log. Okay, and the log of 2 could be calculated with your calculator and you get a decimal approximation. So this is considered the exact answer because anything else would just be a decimal approximation. Okay, all right, so let's take a look at the next one. So we can, again, we've got a log, the log of 3 to the power x minus 4 is equal to the log of 2. So we can use the power property to bring that x minus 4 out front. Now don't forget when you're doing this, it's the whole thing, x minus 4 times the log of 3. So don't forget your parentheses here, otherwise it will be wrong. So just rewriting this using the power property, we get the quantity x minus 4 times the log of 3 is equal to the log of 2. And then if we want to solve for x, well, let's see. We first of all should probably divide by the log of 3. So we get x minus 4 is equal to the log of 2 over the log of 3. And then we just have to add 4 to both sides. So we get x is equal to the log of 2 over the log of 3 plus 4. Okay, that's it. All right, we don't want to simplify this anymore. There are some common mistakes that happen, and so you cannot write this as the log of 2/3 or anything like that. All right, just leave it in this form, log of 2 divided by log of 3. Okay, so that's our answer. All right, let's go to the next one. Now, we have an exponential equation that we have to solve. All right, so let's do this. I have 3 times 2 to the x is equal to 10. Now the exponent is only applied to the 2. So it's a constant 3 times 2 to the x. Now we're going to use the equality property of logarithms. The equality property of logarithms allows us to basically take the log of both sides. If I have 2 equal things, the log of those 2 equal things is also equal. So I can rewrite this as the log of 3 times 2 to the x is equal to the log of 10. Okay. Now I could use log, I'm using the common log, the base 10 log. I could use natural log if I wanted to. It doesn't really matter too much. I just use log base 10 because I'm seeing a 10 over here. And I can simplify that, right? That's just equal to 1. All right, now I have a product, right? I have a product here. So in this left-hand side, we can write this as the log of 3 plus the log of 2 to the x. And this is equal to 1. All right, log of 10 is 1. All right, we still need to solve for x. So let's use the power property to bring the x out front. All right, so, and I'm going to go ahead and I'm going to subtract the log of 3 from both sides. So I'm going to get x log of 2 is equal to 1 minus the log of 3. And then all I need to do is divide both sides by the log of 2. So I get x is equal to 1 minus the log of 3 all over the log of 2. All right, and that's it. That's my answer. That's my exact answer, right? I could put that into a calculator and get a decimal approximation if I wanted to. But it tells us to write these logs in terms of log of 2 and log of 3, so that's what we want. We'll leave it like that. All right, here we have another exponential equation that we're going to solve. We're going to use the equality property of logarithms to do it. I have two equal things. If I take the log of those two equal things, those logs are equal. So I'm going to take the log of 3 to the x plus 1, and that's going to be equal to the log of 20. All right, well, I can bring that exponent out front. And I have to remember to put parentheses around it. So it's x plus 1, the quantity x plus 1 times the log of 3 is equal to the log of 20. All right. Now, I want to solve for x, right? So I can just divide both sides by the log of 3. And I get x plus 1 is equal to the log of 20 over the log of 3. So x is equal to the log of 20 over the log of 3 minus 1 if I subtract 1 from both sides. Okay, are we done? Not quite, because the problem asks us to write this in terms of the log of 2 and the log of 3, not the log of 20. But I know that 20 is 2 times 10, so I can rewrite that numerator. Let's rewrite it down here. I can rewrite this 20 as 2 times 10, which gives me the log of 2 plus the log of 10, right, which is just 1. And then all over 3, and then minus 1. Oh, sorry, log of 3. Log of 3. Okay, I'm starting to run out of room here. All right, so now I have it written in terms of the log of 2 and the log of 3. Okay, now there are other forms that you could write this in, but that's one acceptable answer. Alrighty, well, I got one more example I want to go through, but I'm going to put it in another video, so I'll meet you in that next video.